Hey, welcome back to Networking at Scale. Thanks, John, for your talk. It was really informative about some of the problems you guys are seeing on the Comcast network. So I'm going to talk a little bit about how we rolled out IPv6 on the Facebook backbone over several years, both leading up to World IPv6 Day and then our later efforts to dual stack the network and sort of get IPv6 as a native mentality everywhere. So when people think about Facebook, everybody usually thinks about OCP and giant data centers, warehouse scale stuff, but we also have a large global backbone as well. And just kind of wanted to talk a little bit about sort of the drivers around why we started moving to IPv6 and really started taking it seriously on the backbone. So deploying IPv6 was a chicken and the egg issue for us, and if you guys have been around long enough, you probably saw Don Lee's post where he called it exactly that. So in 2011, we decided we're going to join this consortium of other content providers and try and get IPv6 turned on our network for one day and see what worked and what didn't work. The problem was there wasn't any content, so there was no adoption, so we weren't sure how many users we'd have, and then since there was no content, there was no adoption, there was actually no drive to implement any kind of standards to support IPv6. So we're in a position where we weren't really sure what was going to happen, but we got together with this group of people and said, well, let's find out, and then we can sort of debug afterwards with the other service providers, content providers, and vendors, and figure out what's working for us and what's not working for us. The idea for World IPv6 Day was really that we would just try and get a minimal viable product for the site and see how things were working. So if you've been around long enough, you probably started seeing all these notifications and dire warnings around 2007 that we were in imminent danger of running out of V4 space. And the latest predictions were around 2011 we'd be done, and nobody was more surprised than me when last year the RIRs finally said there's no more IPv space. Have to get in line if you want more V4 space. So we definitely had a lot of the same IPv4 challenges as everyone else. We got the same /8 everyone else did, 10/8, and in 2011 we had a fraction of the data centers and POPs we have deployed today, but we were already running out of space. Our IPv4 plan was really bad because no one thought a website where people shared videos about cats was going to go gangbusters. So already strapped on private space, hard to get public space. RIRs are telling us, hey, V6 is a thing. We're not going to be able to give you the space to keep growing. And we definitely were afraid of renumbering. So we sat down, we talked about it, and we thought, okay, well, we could go renumber this V4 space. Maybe by the time we finish, we'll be out of space again, or we can see if we can get IPv6 to work on backbone. So we decided to buy into the World IPv6 Day, see what we could do to try and make IPv6 reality on our network. So we have a motto sort of internally that done is better than perfect, or pragmatism over perfection a little bit. So when we started working on IPv6, we knew a lot of things were going to be broken, and we just figured we'd do the best we could to get a minimal viable product to serve the website. This started with IGP migration on our side. I won't say that we really needed an IGP migration, but everyone liked to argue about this kind of stuff internally. So we decided we'd discuss the pros and cons of ISIS versus OSPF, which probably anyone who was deploying V6 around this time had the same conversation. At the time, there was no RFC 5838 support, and we were running OSPF, so we knew we'd have to dual stack if we wanted to continue using OSPF, V2 for V4 and V3 for V6. And we were going to deploy MPLS-T to continue to scale the backbone network. We have a fairly large MPLS-T deployment today, and we thought maybe the TLV extensions that are built into ISIS might facilitate that rollout for us a little bit more easily. So we sat down and discussed it, read this book that probably everyone else has read, about the pros and cons of each, and decided we'd do what all the cool kids were doing and roll out ISIS. So we knew it'd be less operational overhead to support a single IGP instance instead of two, and we picked wide metrics, big flat level 2 domain, and went with 31s for V4 and 127s for V6, so we didn't have any DIS elections to worry about. We chose single topology over multi-topology ISIS, but this is kind of a funny anecdote. It was more like that was on by default, and actually got bit a few times by not dual stacking when we rolled this out with black holing and some other issues. So once we rolled the ISIS out, we decided we used route preference to migrate from OSPF to ISIS, and did that region by region over a few months. So we're moved to ISIS, and now we actually want to put V6 traffic on the site for our IPv6 day. We went to our IRs and started asking for address space, and surprised there was no line for V6 space because nobody was really working on it then. We got a /40 from Aaron that we're using today for infrastructure space, and then 332s that we decided to split up and use 132 internally. We treat it like private address space. We decided ULA wasn't the right option for us. We really didn't want to reinvent the wheel, and we were already using the 10/8 space today internally for our data centers. So we figure we'd pick one of these 32s and treat it like private space, so we wouldn't have to basically reinvent the wheel for all the things we were doing today in terms of tooling and provisioning and also our security posture. The other two 32s we use for public deployments. We advertise these addresses to the internet, and they're globally accessible. So now we need a plan to dual stack the site. So again, minimum viable product. We started by dual stacking a couple load balancers for World IPv6 today, one on the West Coast, one on the East Coast, and we were actually proxying V6 traffic to V4 traffic internally for World IPv6 today. The dual stacked and native clusters that Paul talked about earlier didn't come until much later. And we actually use a different quad A record at www.v6.facebook.com instead of www, because we're really concerned about interoperability issues and broken users. Well, everyone hears move fast and break things and jokes about that stuff, so you wonder, why were we concerned about quality of access to the site and users? Well, if you'll remember, this was 2011. This was right before we were going to IPO, and we were under a lot of scrutiny, and we were already serving 500 million users that depended on the site. So it was very important to us that the users continue to have good quality of experience, and that as we roll out V6, we tried to keep it as seamless an experience as possible for the end users. So we have our plan. Let's start dual stacking. Well, you might go to Danlog or read papers today and hear about all the great automation stuff we're doing on the backbone and in the data center, but at the time, that really wasn't a reality yet. We were thinking about this stuff, but it wasn't here in time for the rollout on the backbone. So we were doing a lot of manual work to get the network dual stacked. So that means engineers logging into routers, configuring second IP address, configuring second BGP sessions, turning up additional adjacencies to other routers, and we didn't even have good address allocation or management tools at the time. We were using DNS zone files to track with reverse entries what was being assigned where, which led to double allocation, routing loops, and a lot of other problems on the network as we got the stuff rolled out. So we did make a big push externally to turn up IPv6 sessions with all of our external peers. And you guys probably, many people in this room were at the end of many of those naggy emails as we asked you to turn up V6 sessions with us. The idea was we'd have more flexibility if we went dual stack for BGP. We knew one day we were going to peer with V6 only networks, so we didn't want to have shared fate for V4 and V6 with our BGP stack. And then we already had some concerns with some code we looked at internally about weird next hop problems with V4 and V6 sessions shared. So, great plan. Everything was super flawless, right? Not exactly. So, once we started rolling this stuff out, we actually figured out a lot of operational things really didn't work at all. Collections, show commands might show different things when you're thinking you're looking at the same information, if it showed anything at all. A lot of XML output was broken or buggy, and there were special or hidden commands that you guys have probably all seen that were even required to sort of turn on collections for some things at all. So it was sort of a frustrating situation where the traffic's starting to ramp up. You don't really know what's happening on the box. You have to go to the vendors and get collections run directly off the hardware to figure out which strange obscure counter on the box is counting up for what, and figure out, okay, is this V6 traffic? Is this not V6 traffic? Is this a broken vendor thing? Is this not? So one thing we definitely found out is that operationally, the control plane stuff might work, but operationally, the boxes weren't really at a point where they were easily supported by most people at this time. So one of the more painful examples, which is just kind of a funny historical footnote now, was that RFC 5952 implementation was totally different in every vendor implementation. For you guys who are unfamiliar, that's just the RFC that dictates how IPv6 addresses are supposed to be textually represented when they get compressed. So these three addresses are actually the same address, but as far as some of our vendor implementations were concerned, they were actually different IPs. So one guy goes and puts on an address, and then somebody else goes and manually changes it later, and boom, your BGP session bounces. Or I go push a new IBGP mesh, and boom, you lose a bunch of routers because the IP address changed. So that was a little bit alarming to find out, and it took a little while to get solved. So flying blind, right? Like no idea what's going on with these collections, weird behavior with different things that are implemented, and then we don't have NetFlow. In fact, we didn't have working NetFlow until the end of 2015 on most of our platforms. So if you want an IPfix or an updated NetFlow alternative, you're even going to be waiting longer than that. So for those of you counting, 2015 was just a few months ago. So obviously we're not running a site at Facebook scale without some kind of visibility about our traffic flows. We actually wrote a software stack internally called FBflow that we run on our hosts to collect flow information to and from data center and hosts in our edge pops to be able to tell where traffic was going and what it was, because we didn't have NetFlow and we needed it to run the site. So this runs on the hosts. It samples TCP and UDP traffic, and then we export it to our custom NetFlow application that we then use to extrapolate data about traffic growth with hosts, flows on the backbone, things of that nature. But at the same time, FBflow solves a lot of problems on the host. It doesn't solve all of the network problems. If I want to see what long flows are happening between two LERs, between two data centers, I have no way to tell which LSP this traffic gets mapped on. So it's still a little bit of a whack-a-mole game, and we're still working with vendors to get this figured out. But it looks like we're in a little bit better shape, at least here today, than we were a few years ago. So if you guys have been following along, you noticed I probably missed a step. You said, okay, he did this IGP migration, and then they're going to roll out MPLS-TE, and then what happens with the V6 traffic, right? Well, let's put this fire over here. We're IGP routing V6 at this point. So for anyone familiar with what the MPLS rollouts were like in the early 2000s or went through that themselves, you know that, if you want to use RSVP-TE, you definitely are not going to IGP route your IPv6 traffic. So we needed some kind of solution to stop IGP routing V6 traffic and make use of all this MPLS-TE work we had done because our traffic was ramping up. So no one had a working RSVP v6 implementation, and I don't think anybody really does today. It's still a lot of hacky solutions to make any kind of MPLS-TE and IPv6 stuff work. And we were looking at a BGP-free core at the time, so we wanted to know, okay, how do we get our IPv6 next hops on LSRs? And then no one had a working RFC 5549 implementation, so 4 and 6, you're out of luck. So internally, we talked about this. We weren't 100% sure how we wanted to solve the problem, but we did have a few ideas. So first option was IPv6 tunneling. It was less BGP state and the simplest configuration, but we would have had to bounce all the BGP sessions on the network and dual stack our LSRs. BGP labeled unicast, or 6PE, was the other option we heavily considered. Less BGP state, no LSR dual stacking, and we would have end-to-end LSPs if we decided at some point we wanted to regionalize our MPLS-TE topology. The downsides were we'd have to bounce sessions and add new BGP, AFI, and SAFI. The last option was IGP shortcuts or auto route announce, and no BGP changes because we had already dual stacked. Flexible for dual stack environments that we've been rolling out, but more BGP state, and we had to change all of our LSP metrics to be smaller than our IGP metrics. Well, lots of thought went into this, and right away it looked like IPv6 tunneling really didn't fit into our goals because we knew we wanted to move to a BGP-free core, less features, denser platforms for LSRs, so it wasn't really a good fit. IGP shortcuts and BGP labeled unicast were a little bit of a toss-up. Either one really looked like they'd be a good option if you squinted, but we were concerned about the work that would go into bouncing all the BGP sessions on the network. It looked more impactful, and IGP shortcuts really looked like it was just going to be a simpler implementation. So we went with IGP shortcuts for the IPv6 traffic. So now that we're finished on the backbone, Todd will talk a little bit next about what you were doing in the data center at the same time. We went back to start working on dual stacking and building native IPv6 in our edge POPs. So one thing we definitely learned from doing the work on the backbone is that without automation, this is really, really difficult to do for us. We would have never been able to do the data center work without what we learned on the backbone side that fed into some of the automation efforts that we had internally to develop tooling and also change architecture so we were able to drain devices basically to implement these changes. It's a lot easier when you can take a box out of service to make the changes you need to make and then put it back into service versus making multiple iterative changes over, however long it takes you to roll this stuff out. So even though we had automation at this point, the work was still really operationally intensive. We had tooling at this point, but we still had to drain all of our POPs, upgrade software on the switches, and then convert from layer 2 to layer 3 topology to be able to implement these changes. So if there's any takeaway from this, it's definitely that we didn't flip a switch. It was a lot of work over a long period of time here for this work in the edge. And being able to move fast requires automation at our scale. There's no way we could have done this without what we learned on the backbone and what the data center guys ended up implementing in the data center. So just to give you guys kind of an idea where we are in terms of adoption today, Mark likes to say this journey is 1% finished. So maybe that's a little bit of a misnomer, but I still feel like we have a lot of work to do, as Paul sort of pointed out earlier. Going back to the first slide, when I talked about exhaustion on IPv4 space, we would have never been able to continue scaling the site with our IPv4 plan as it was. Facebook actually might not be around today if we hadn't gotten in front of this early and had some kind of alternatives to be able to support the data center and POP growth. World IPv6 Day got us thinking about the problems, and we knew we were going to be impacted, so we decided we had to do something and figure out what it would take to get the site dual stacked and get a minimum viable product. Today we have all of our peering and interface provisioning automated, so all of these painful manual provisionings and IP management and zone file stuff is a distant, painful memory. And we're definitely pushing our vendors to implement V6 first as a mentality for all new features and platforms. So what takeaways would I leave you guys with from all of this? Well, first is if we had waited until everything was working, we probably wouldn't have started this until last year and it would have been too late. If we had sat forever waiting for NetFlow and instead of working on our own NetFlow stack, and yes, we do control our own stack, so maybe that problem is a little bit easier to solve, but I mean, just think, what can you do to start today? It doesn't have to be like dual stack your whole network in 6 months or 1 year or whatever. John talked about working on it in Comcast for 10 years, but what's one thing you can do today to make IPv6 reality in your networks? The other thing is that a good addressing plan is the most important thing for you guys to get right when you start thinking about this. IPv4 renumbering was a pain, and you definitely don't want to go through the same hassle and heartache again with V6. In fact, I would recommend that you look at the resources, a couple slides I have here up, to sort of start thinking about how that fits in to your IPv6 deployments. The other thing is that the architecture decisions you make today definitely impact your choices in the future. But as John pointed out, there's a lot more choices and a lot more people doing this today. So you have a lot more options in terms of how you choose to deploy v6 on your network. And it's important to make good decisions, but you definitely don't want to get stuck in a state where you discuss this stuff forever. Do something right now to make this a reality for you. And then there's a lot of people here who have already done this. You know, John talked before about how they were doing this Comcast. Paul talks at every v6 event there is. We're definitely willing and happy to help talk to you about how you can make this work in your network. And then I just wanted to leave you guys with sort of a timeline to give you an idea that this didn't happen overnight for us, but we were working at it very consistently over, as early as 2008. So one thing here on the slide I kind of do want to point out is that it wasn't until 2014 that we actually started turning up our first native v6 clusters. And then in 2015, all of our clusters except for one was native v6. And then as of today, 99% of our internal traffic is v6 only, and 15% of our egress traffic to the internet is v6. So definitely come a long way, but as you can see, there's still a lot to do. We're very interested in helping you guys get your networks dual stacked, and we'd love to be able to up that 15% to more like 99 or 100. So just wanted to leave you here with a few resources. Omar's team presented about FB Flow at a conference earlier, either this year or last year. And then a few RFCs here we talked about, and then some IPv6 numbering plans and resources. So thanks a lot. I really appreciate your time. Questions?
It might be more of a comment, but
Sure.
I'd like to hear your thoughts. I remember on World IPv6 Day, one of the efforts I was doing was trying to measure the performance of Facebook on v4 versus v6.
Mm-hmm.
And one of the interesting things I saw, and sort of as a reminder to the audience, when you have something like a web property, it can be dual stacked itself, and thus dual stack clients access it in a hybrid mode. So we saw the Facebook main page coming down on v6 and the chat stuff going on v4.
Yep.
So it's a complication that arises from that. Do you think that, do you have any components that are still like that? Or do you see, because of happy eyeballs, the clients choosing to do that? And what I'm interested in is how much simpler it can be when it's v6 only versus dual stack.
Yeah.
Dual stack causes a lot of pain.
I mean, there's definitely, pockets of things that are still like v4 and v6 that people access. And just to kind of give a plug for our network cache, Facebook network appliance, right? Even that stuff, we're kind of taking a v6 mentality first with like the cache fills that device does. We try and use v6 wherever possible. But, there are still like other Facebook properties or things that, are mixed like v4, v6, dual stacked. And, I won't say it's like from a lack of effort, but it's more like a low-hanging fruit thing. Like if I took Paul's graph and tried to show like what v6 migration looked like on our backbone, it wasn't really like this hockey stick curve. It was more like this jagged, like move a service, jump up, go flat for a little while, move a service, jump up, go flat for a little while, kind of thing. So, and the kernel guys will talk about this a little bit more, but I mean, it's more like, what's the low-hanging fruit for us? And that's kind of where we started. If I go back to the timeline, I don't know if I can. There you go. In 2014, when we started migrating services, right, every week you kind of see like, like however many hundred gigs of traffic has moved because the service moved, and you just sort of see the step function. So for us, it was always kind of like, okay, what's the easy stuff that we can get on v6 right away? Sort of like that pragmatic view, like what can we do right now, and then the stuff that's hard to fix that comes later.
I'm sure that besides having your own problems and your own anecdotes when switching to IPv6, you've also seen issues that other networks have, right? Mm-hmm. Networks you peer with or networks your customer requests are coming from. So what do you do if some of these networks have routing issues, or they have loops and the traffic goes into a black hole, or the traffic gets routed through another continent, what do you do in these cases if you see that these networks really have issues on IPv6, then maybe they don't have them on IPv4. Do you blacklist them, or do you talk to them, or what is your approach?
Yeah, so we try and work with them whenever possible. Actually, it's funny that you mentioned that because I just worked with a large ISP the other day with a similar problem using WhatsApp. They were having traffic black hole related to path MTU stuff that Paul kind of joked about earlier with IPv6, but it actually turned out to also be an IPv6 related issue. And in that particular case, they decided to shift the traffic through another provider until they could work out the issue on their network. But yeah, I mean, I would say it's a case-by-case kind of basis, but we definitely try and work with people wherever possible because, from our point of view, it's better for our users and for our network, right, if we just support v6. So we would prefer that everybody reach us over v6 if possible, and we want to help people make that a reality however we can.
So something that's really interesting and why Happy Eyeballs is actually a bad thing now is there was a large carrier here in the United States who had turned on dual stack last year in April on the Galaxy S6 and all newer devices. And what happened was they, like a week or two later, they had a routing issue. And the only reason that they discovered it was the support calls coming in where I can't get to Facebook. And then let's fast forward 2 or 3 months, and they had a routing loop in Seattle. But we had rolled out Happy Eyeballs. They didn't know about this routing loop for days. So like we actually take the standpoint of we would rather the networks be broken so that people can go and fix the issues rather than black holing and band-aiding over the problem, because v6 is a first-class network, not a secondary network that can be turned off.
Good point, Paul.
So when you say NetFlow is working in 2015, right? So
yep.
Does all the vendors supported it? Like how is your vendor support with respect to IPv6?
Yeah, I mean, I would say that our vendors definitely understand for us now because we've made it first in all of our discussions with them that this is critical for us, right? Like we won't even look at a platform if it doesn't support IPv6 at the level we need it to. Just because, I mean, if you look at that number, that's a reality for us, right? Like 99% of our traffic on the backbone is v6. If it doesn't do everything we need it to do, or at least the things that we can't do ourselves, then it's a non-starter conversation for us. So in the case of NetFlow, at the time, v6 traffic wasn't very much. We thought, okay, maybe this isn't such a hard problem to fix, but when it became a longer running problem for us and, we developed that people internally, it became like a good, band-aid to the problem for us until we could get NetFlow worked out and then be able to glean additional insights about LSPs and flows and which LSPs they ended up on and things like that. Hey, Joe.
Hey, Will, John Brzezowski. So, on the NetFlow comment, I think we've been in a place where we've seen it working. The trick is getting everybody to configure it correctly. It's been, a recent dilemma for us. But on a side note, curious, kind of a forward-looking question for you. Do you see any opportunities on the horizon as it relates to MTU in v6? Larger packets, more data and fewer packets?
Yeah, it's actually funny. I was just joking with my manager about this while we were getting coffee. Is like, will we ever have like jumbo, internet MTU? I don't know. I mean, I think it's definitely an opportunity. His joke was like 1,600 bytes jumbo MTU, right? But I don't know. Yeah, I mean, it would be great if we could push for something larger. But I think that's kind of akin to what Peter brought up yesterday and like trying to change BGP protocol. There's a lot of stakeholders, so it's a little bit harder thing to push for. But who knows? Nothing's impossible, right?
Oh, we can't do one more? Let's just Martin.
There you go. Good question. Yeah, I'm going to ignore the jumbo frame statement for the moment. Those that know the pain I've gone through in that. Back a few slides, you talked about your ISIS choice of
yes.
multi-protocol or not.
Uh-huh.
And you did, in fact, actually what a lot of people have done is, that's the default on vendor de jure.
Yep.
And you left it that way. Can you go back and look at that and sort of say, if you know now what you know now, would you have done it differently? And I know there are, the caveats of going multi-protocol, which in theory is the biggest win of picking ISIS as that move over OSPF.
Yep. So it's funny. It's not just the single topology thing, but there's even other choices that we made, like IGP shortcuts that I referred to earlier, where as recently as about a year and a half ago, we were evaluating a new platform and had performance problems basically due to the architecture of the hardware that forced a packet recirculation to pop the second label. So for us, I think that we're pretty good about revisiting this stuff. I mean, in terms of, would we make an effort right now today to go back and switch from single to multi-topology? I think probably that's a little bit further down the list of big wins for us, but, maybe. Knowing what we know now, yeah, we probably would have turned on multi-topology by default because we got bit by it a few times while we were doing the rollout. I think it was just far enough along that people didn't want to sort of revisit it. But I would say at Facebook, any of this stuff is probably up for debate at any time. It could be changed. We're pretty aggressive about optimizing and changing things on the network as we determine that it provides concrete benefit for the services. So yeah. While it's up for debate, it's probably one of those lower hanging fruit things that we would, maybe get to after we've connected the entire world or something like that. So,
sorry, if I can just quickly follow up on that then, and sort of helping you answer that. Do you have enough network automation tools to make 2 configuration setups look like one? In other words, in a multi-protocol environment, you in theory should have half as much configuration within that domain.
Yep.
Have you got the networking automation tools to make that equivalent within a single topology setup?
Yes, we do. We could do that today. I guess that's one of the things now that we definitely learned from all this rollout stuff is the tooling. We definitely moved to a tooling first mentality about these things. We don't really make changes on the network even to do testing or trial stuff without actually sort of codifying it in our tooling frameworks. So we know this thing is a one-off, and we have some kind of tracking for it as a one-off or whatever. So if we did want to go out and roll out this change, it is something that we can model in our tooling today and then push that change to the network.
We got to go to the next speaker.
Okay. I'll follow up with you afterwards. Thank you.